recording is on. Today's lesson is a continuance of differentiation rules. Yesterday, let me just write rules, lesson number 2. Yesterday, I told you that if you have a function, let's say 3x squared minus 4x, and we need to differentiate that, you get the first derivative, but you must make sure that x has an exponent and a coefficient. An exponent and a coefficient. And then you can differentiate. 2 times 3 is 6x. 2 minus 1 is 1. Minus 1 times 4 is 4x. 1 minus 1 is 0. And then you simplify. 6x minus, this is 1 times 4 is 4. Now what happens if I give you a function like y equals 2x plus 3, 3x minus 2? When the function is still a sum, what happens then? You must first simplify it. Okay. So y equals, first time first, 6x squared. Then we get 9x minus 4x is plus 5x. Plus 3 times minus 2 is minus 6. Make sure that every term has the correct form. There's an x, exponent, and a 6. An x, exponent, and a 5. An x, an exponent, and a 6. And then you can differentiate. So, dx of 6x squared plus 5x minus 6 will be equal to 2 times 6 is 12x, 2 minus 1 is 1, plus 1 times 5 is 5, x to the power of 0 is 1. This 6 has an exponent of 0. 0 times 6 is 0 plus nothing.
Ma'am, would it be wrong to do it like bracket by bracket?
Yeah.
No, at the top. Instead of simplifying, I started with the first bracket.
Yes, it will be wrong. You have to simplify it so that you have an expression as a straight line, without any brackets, without fractions, without outserts. Okay.
I don't understand how you got nothing. Because the x has an exponent of 0, and if you minus 1 from 0, it's negative 1.
Okay. 0 times 6 is 0.
Oh, okay.
Okay. Right. Let's look at another one. There are some more papers. Dx of 16 over x to the power of 3 minus 16 over x squared. Now we have fractions. You first have to write your expression without fractions, especially when your x is in the denominator. So dx 16 times, I have to take this x to the power of 3 to the numerator. So it becomes what? X to the power of negative 3 minus, take this up, 16x to the power of negative 2. Okay, check the form. I have an x with an exponent and a 16. I have an x with an exponent and a 16. So now I multiply the exponent with the coefficient, so it's negative 3 times 16 x to the power of negative 3 minus 1. Minus, take the exponent, negative 2 times it with 16 x to the power of negative 2 minus 1. And now you simplify. Minus 3 times 16 is negative 48 x to the power of negative 4. A minus times a minus is a plus, 32 x to the power of negative 3. Can I leave my answer like that? No. Why? Negative exponents. You are very, very clever. So this must go down and this must go down. So the negative 48 stays on top, x to the power of 4 plus 32 on top, x to the power of 3. Any questions? Let's look. Okay, now we did. What do you do when you have brackets? You first multiply them. What do you do if you have fractions and the x's are in the denominators? You take them up. What can you do if you have surds?
Put the whole thing out under the square root.
Okay, I have a square root. I must get rid of the square root.
1 over 2.
Yes, but you only do that with x. You only take the x out of the surd. So if x will be square root 5 times x to the power of 1 over 2. Okay, now I have an x, I have an exponent, and I have a coefficient. The first derivative of x will therefore be this exponent times square root 5 times x to the power of half minus 1. Square root 5 times a half.
Why do you keep
Because the 5, you don't have to differentiate the 5. 5 is part of the number. Okay. Square root 5 times a half is square 5 over 2 times x. A half minus 1 is negative a half. Can I leave it like that? No. So this must go down next to the 2. Square root 5 over 2x to the power of half. And you can go further. You can say this is square root x.
You need to go a step further to hold get a half and a half x.
You can leave it on. Okay, now I want to do another example. Let's say I give you two functions. Y equals 2x, 3 minus x, and I give you z equals y over 2. Now we first need to simplify this. So y will be equal to 6x minus 2x squared. And in this case, z will be a half y. The first question, dy over dx. What does that mean? Take y, differentiate x. So take y and differentiate x. Okay? I have my coefficient. I need an exponent. There's x, exponent, and 2. That will be 6 times 1 is 6, x to the power of minus 1 is 0. Minus 2 times 2 is 4x. 2 minus 1 is 1. Simplify that further. This is 1 times 6, 6 minus 4x. Okay, number B. dz over dy. What does that mean? Take z, differentiate y. Okay? Y has an exponent of 1. So that means it's 1 times a half is a half. Y to the power of 1 minus 1 is 0. This is 1. 1 times a half is a half. Okay. Now the jackpot question. What happens if I ask you this? dz over dx. Take z and differentiate x. Does it have an x? How? No. 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 Okay, think further. Think further. Yeah. We're going to substitute the y with this. Okay, so this, therefore z will be y times 6x minus 2x squared. And then you will get 6 times a half is 3x. Minus 2 over a half is minus x squared. There's a 1. Now I can differentiate. There's a 1 as well. Take z, differentiate x. Okay, 1 times 3 is 3x to the power of 1 minus 1, 0. Minus 2 times 1 is 2x to the power of 2 minus 1 is 1. This is a 1 times 3 is 3 minus 2x. Well done. You are very clever.
So when it's like this, there will be questions that sort of follow on, so you know that you have to see
Yes.
a substitution.
Especially when they say y equals this and z equals that. Okay. Then you must know there will be a follow-up question. We have to combine something somewhere. Your homework for tomorrow, for Monday, sorry. Today in class, we did differentiation rules part 2. We did examples 4 to 7. So your homework will be exercise 4, page 17, number 15 to 22. Um, what must we still mark?
Exercise 6.
Exercise 6.